When we are first introduced to the concept of lines, we are taught that the equation of a line is given by y equals mx plus p. And here, p represents the y-intercept. Recall that the y-intercept is the y value for which x equals to 0. And x equals to 0 over here, and therefore the y value on the line is p. Furthermore, the m value over here represents the slope. And conceptually, the slope represents the ratio of the rise over the run. In other words, when we move 1 unit to the right, we move m units up. So the rise represents the change in y values, so y2 minus y1. And the run represents the change in the x values. And so if we move 1 unit to the right, so if our run is 1, then our rise will be of m units. But we have seen previously that generally the equation of a line is given by ax plus by plus c equals to 0, which is slightly different from this expression. So what we want to do now is try to change this expression over here and try to manipulate the variable so that ultimately we get this expression, the general equation of a line. And so what we do is bring y on the other side of the equation, and therefore we have mx minus y plus p equals to 0. And therefore what we have is that m equals to a and b equals to -1. And we get that by comparing this expression with this expression. Here we see that m equals to a and minus y equals to by, b times y, and therefore minus 1 equals to b. Furthermore, we know that if we have the Cartesian equation, we can get the expression for a direction vector. And we know that the direction vector u is minus ba, and since b is -1, minus b will be 1. And a is m. And therefore, our direction vector is equal to 1 in the x direction and m in the y direction. And why does this make sense from a geometrical standpoint? Well, we have 2 points on our line, let's say here and here. And we know that if we have 2 points, we can get a direction vector. Because since the 2 points lie on the line, if we have a vector that links the starting point over here and the end point over here, we can get a vector that is parallel to the line, and therefore it's a direction vector. Hence we get this vector over here, and the coordinates of the direction vector make sense because we move by 1 in the x direction and we move up by m, which is exactly what we have here for the coordinates of our direction vector. So if we visualize it, we can understand why the direction vector u has these 2 coordinates, because it represents the slope of our line. So now let's get a general expression for the slope m. So what we do is we start from the vector equation of our line. So we know that it's r equals r naught plus tu, and we know that u is 1 on the x-axis and m on the y-axis, and therefore we have, assuming that vector r has coordinates x, y, and r naught has coordinates x naught and y naught. Equating the components in our vector equation, in other words, linking the coordinates in this equation, we get that x is equal to x naught plus t times 1, because the x-axis, the x-coordinate of our direction vector u is 1. And similarly for y, we get y naught plus t plus t times m, because the y coordinate of our direction vector is m. What this means is that m is equal to y minus y naught divided by t. But what is t? From this equation, we see that t will be equal to x minus x naught. And from here we get that m is actually equal to y minus y naught divided by x minus x naught. And so this is the formula for the slope. And from this formula we can clearly understand the intuitive definition of the slope as being the rise over the run, because the rise is represented by the change in the y coordinates, so y minus y naught, and the run is understood from the change in the x direction, x minus x naught. And so to quickly sum up, we can get the expression of a direction vector of a line as being, in terms of coordinates, 1 in the x direction and m in the y direction, where m represents the ratio of the rise over the run. Now imagine we have a new line that is directly perpendicular to our initial line. How can we get the slope of that line? And if you are familiar with the concept of the dot product or the scalar product, you will know that if you have a normal vector n with coordinates x and y, then the dot product of u, so u dotted with n, the dot product between the direction vector u and a normal vector n, then that dot product will be equal to 0. And since our direction vector has coordinates 1 and m, we can determine the coordinates of a normal vector to that line, which will be negative m and 1. Indeed, if we compute the dot product between these two vectors, we will multiply each coordinate respectively, so we have 1 times negative m plus m times 1, and so we have negative m plus m, which will be equal to 0. So indeed, n is a normal vector to our line here. And remember that to find a normal vector, the normal vector has to be perpendicular to that line, and since our direction vector is parallel to that line, the normal vector will be perpendicular to and therefore orthogonal to our direction vector. Now that we know the coordinates of our normal vector, we can determine the slope. And the way we go about is first we write the Cartesian equation of our line, knowing that our normal vector n is actually the direction vector of our line that is perpendicular to our initial line. Okay? Since n is the direction vector of our new line, we can write it as minus b a in coordinate form. And therefore we have that b equals m and a equals to 1. And therefore we can write the expression of the perpendicular line in terms of the Cartesian equation, which will be ax plus by plus c equals to 0, and therefore x plus my plus c equals to 0. And we can write that equation in the traditional form: y equals negative 1 over m x plus a certain constant, which we will call d to simplify. The way we obtained that is by moving x to the other side of the equation, and therefore we have my equals minus x plus a constant, and if we divide by m we get negative 1 over m. To summarize, what we have shown is that if we have a line, let's call it L, with slope m, then a line that is directly perpendicular to our line L, let's call it L prime, will have a slope that is the negative reciprocal of the slope of L. In other words, negative 1 over n. Thank you for watching this video. Leave a comment down below, and if you enjoyed it, don't forget to hit that like button.